Hello everyone, welcome to my KaggleX Fellowship Program Project Showcase, where we're going to go through a Mathland chatbot. In this project, I've explored the possibility of using AI to solve mathematical problems. So I'm Martin Koome, an aspiring AI engineer. Currently, I'm a statistics and computer science student at the Multimedia University of Kenya. What truly drives me is the belief that there is always more to discover in this field of AI, and over time, it has become my primary focus. I've also find motivation in creating innovative and impactful solutions that can make a meaningful difference, and also committed to continuous learning and growth in this field. Now, this is what you're going to cover at a high level uh, through this presentation. And without further ado, let's get started. So I focused on fine-tuning a quantized 2B, uh, a, a quantized Gemma 9B model to build a math assistant chatbot that solves mathematical problems from the user in a step-by-step manner. What truly inspired me to focus on this domain was the challenge that we mathematics students in my institution faced while using the open available models to tackle critical units in statistics. So the problem was that uh, they provided a, a solution, but at times they missed key steps which which they used to arrive at the answer. So it was really hard to follow through, and therefore I saw a need to develop an educational tool to address this challenge. So I fine-tuned the model using a custom chain of thought structured dataset to enhance its problem-solving skills. So before starting the project, I saw it fit to visualize what I wanted before anything else. So this guided me in planning and knowing what to do next, and implementing research uh, on areas that I wasn't proficient in. So this is the model pipeline from data ingestion to generation. So the data sets that I used a Numina chain of thought data set. Actually, it was developed by the previous winner of the AI Mathematical Olympiad, and also Orca from Microsoft. This is generated using Azure GPT Turbo. So it is designed to enhance mathematical reading capabilities of large language models. So I did an EDA. This is an EDA on the Numina. It had 4 columns: the source, the problem, the solution, and the message. So I used the first 3 columns in this project, and I really wanted to know the source of this problem solutions, really rather, to ensure diversity in the fine-tuning datasets. So there were a few sources, of which the K-12 online seems to dominate. Uh, okay, now the data pre-processing, I pre-processed using the tokens that are key in the 9B model. So here the problem variable holds the question, and the response variable holds the solution. The templates. Now here I learned key prompt engineering techniques, where I was intrigued by how the model's results differs by just a slight change in the prompt template, or the prompt. Yeah. So I stuck with using a persona, which really made the model to understand what really it is to do. So I gave mine a persona of a professional math assistant, uh, and giving it clear steps on how to uh, solve and give the user the solution. So here on the fine tuning part, I used the color Q LoRa approach, where I fine tune, where I use the parameter efficient method. So I used a rank of 4 to adjust the number of trainable parameters. I also chose a small running rate, uh, about 0.03, and used a weight decay of 0.01 to reduce overfitting. I used the supervised fine-tuning trainer and trained the model for 10 epochs. So I also used a powerful A100 GPU, which was key in this project. Now, the model evaluation part, I I first approached it in from the basic steps and then explored other wider steps. So I prompted using some few questions after and before fine tuning and noticed some improvements. I also explored using sentence transformers, which also uh, showed an improvement. The last one I was a bit skeptic about it because it uses the overlapping n-grams to check the accuracy. But in maths, you see, uh, you could approach different mathematical questions in different ways. So that was not that much efficient, but the model showed an improvement on that also. So I also implemented a retrieval system uh, to using the Orca dataset where I pre-processed the data using a recursive character uh, character text splitter and then indexed the chunks in a Chroma database. So here I was challenged a bit. Also in the QLoRa Pro section, I was also challenged. So here the main issue was uh, getting a relevant context that is related to the query because I was getting a very large context, probably from a similarity method from the ranker, but it was not relatable to the query asked. So this was the main challenge, and it is an area that I've planned to execute as further research in my research on exploring mathematics ability of large language models. Other areas that I would like to research, put future work on uh, are to use other models that are more specific to maths, like the DeepSeek 7B model, and also challenge my pipeline on the current IMO competition. I deployed the model on Hugging Face and also on Kaggle and prepared a script that launches a Streamlit app. So here's the model in action, and I liked the way it was staying relevant to the conversation, and yeah, it knows what it does. It was able to solve a few questions here and also in the notebooks as well. So the main issue here was uh, including history in the conversation. So I was using a list to store our previous conversations with the Matlan model, and it was really challenging to include the history because of the context window of the rather the max output tokens which had specified. So yeah, it was a bit challenging to include the history, but I'm also working on that. Yeah, so this is the model in action. Uh, it is able to solve, and actually in this question it is able to detail how it solves these simultaneous equations. So it says that it uses the method of substitution. As you all know, there are many methods. There are completion of square methods, there's matrix methods, yeah, and there are other many methods to solve simultaneous equation, but it details why it uses it, why it is key. Yeah, you can explore more on my GitHub repository. So what I've learned in this project, I like the way that I was learning through implementing rather than just having the domain knowledge, and this helped me to learn. Uh, I've learned fine-tuning, how to fine-tune a large language model for a specific task. I've also learned how to develop a model pipeline from data ingestion to output generation, implementing databases, prompt engineering techniques, and I've also learned how to manage projects on GCP thanks to the KaggleX program. So what I found challenging was working with the quantized model. Uh, this made me work late nights of debugging, but I thank everyone who advised and provided feedback. So also configuring a virtual machine instant with TPU and with TPU and GCP was also challenging. Also saving the 9B model. This is what led me to use the quantized model. Also building the user interface was quite challenging. These are the project links. You can, if interested, you can explore my work. I included everything. I'll actually include my second variant, which I was using the 9B, uh, which is not quantized. So I'd like to thank my advisor, Uzordinma, for the continued support through this program. I couldn't have done this project without his guidance through the past 12 weeks. Thank you, sir. I also like to thank the KaggleX for this incredible opportunity for career and self-development. Uh, it was truly an impactful journey. So I'll also thank the fellows and the advisors who are readily available to answer questions posted on Copa and also those I reach out to personally. I appreciate all of you. Thank you.